Welcome to the next part of the randomizer lesson in day 5, part 3. We're going to actually create the fundamental class that will allow us to actually play a game of Boggle by creating something we're going to call a Boggle board to hold many of our Boggle dice. So what you see before you is a set of actual Boggle dice. There are 16 of them. And the Boggle dice are designed so that it's easier to make words when the dice are rolled randomly. So you'll see certain letters represented more often than other letters. Obviously, Z should be less common than E if you want to make it relatively easy to form letters. So we need to know what's on each side of each distinct Boggle die. There is no such thing as a Boggle die. Each Boggle die is unique, and so we're going to have to create them somehow. And then, of course, we're going to need to make the game playable. And the way the game of Boggle works is the dice are put into this rack here. It's covered with a clear plastic bubble. You shake it, and so the dice pop around and move into random locations and change sides. And when you stop, you remove the cover, you start a timer, and then you begin trying to find words out of the letters that you see. For example, I see N-E-T here, so I could spell net. I also see N-E-W-T, so I could spell newt using those same letters. You can go any direction as long as you don't use the same die twice in a word, and you can't skip a die. Those are the very super simple rules of Boggle. So what are we going to do first? Well, let's get into Eclipse and quickly review our Boggle die. Our Boggle die is always a six-sided die, and we construct it by giving it a string of letters, and it should be a string of exactly 6 letters, which then gets turned into an array, which is then used to create our Boggle die by assigning each letter to one side of our die. We have one special case when we convert a Boggle die to a string, which is the letter Q is treated as QU, otherwise you would almost never be able to create a word that has QU in it. So any other letter should always be an uppercase letter, and it should just be a single letter. All right, so now let's create our Boggle board. So we're going to create a new class, which we'll call Boggle board. We'll click Finish. It's not going to be based on any existing class. And then we're going to get right to work here. This video is going to be a little bit longer than most, so I'm going to skip the Java docs and trust you to put those in. So first, let's just create our outlines. It's been a while to remember us of the anatomy of a class. Typically, we have instance variables. We also have constructor methods. We also have getter methods, and we frequently have setter or mutator methods. Okay, so let's see what we can fill in. Well, let's start with considering how we're going to store our dice. If you recall back to the image of the Boggle board, it was a container that could hold 4 rows of 4 dice. That should immediately call to mind some kind of structure that you're aware of for storing data. Hopefully, you've realized that it should be some kind of array, and a 2-dimensional array at that. So we're going to create a private array, which we're going to call an array of, oops, we should make that lowercase, of Boggle dice. And it's going to be a 2-dimensional array, and I'm sorry, that's the class, so it's a Boggle die array. And because we're storing multiple dice in the array, we'll call it Boggle dice. All right, now that declares our Boggle dice instance variable. Now we have to consider how is it going to get populated. And for that, we're going to set up some nifty little values here that we can use. Now, if we're just limiting ourselves to a Boggle board that can only have 4 rows and 4 columns, we could stop right there and start our constructor. But what if we want to leave this open-ended enough so that we could easily change the number of dice at some future time? Well, in that case, we might want to have some instance variables that lets us set the number of rows and columns in our Boggle board. And there's actually, in fact, a game called Big Boggle that has a larger board, so that's not that far a stretch. Now, we're going to want to just always, for right now, for this version of the Boggle board, we're going to lock it down with 4 rows and 4 columns. So we're going to write our constructor, our default constructor, which is going to be public Boggle board. And then we're going to give our number of rows as 4 and our number of columns also as 4. Oops, we have to do those as separate lines. There we go. Okay, and then we're going to create a variable that will allow us to keep track of how many dice we've initialized so far. So we're going to say int die index equals 0, and we're going to use that within our loop to allow us to navigate an array that we're going to create right now. So what is this array going to be? Well, it's going to be a string array that's going to be a list of all of the dice, and you can find a copy of a list of what dice are in standard Boggle online, or you can watch here as I type them in. So the first Boggle die has AAEEGN, the second one has ELRTTY, the third one has AOOTTW, the next one has ABBJOO. I'm going to go to the next line just so my lines don't get too long here, and I'm going to put the next one as EHRTVN, then CIMOTU, and then we're going to have DISTTY, and on our next one we're going to have EIOSST, and then we're going to have GELRVY, and on our next line, our next Boggle die is going to have ACHOPS, and then we're going to have for our next one HIMNQU. Now keep in mind that that's the letter Q that's going to be QU and the letter U as separate sides. And then we're going to have EEINSU followed by EEGHNW. And on our next die, we're going to have AFFKPS. And we're nearing the end here. HLNNRZ. And then finally, DEILRX as our last Boggle die. We'll put our closed curly brace in. And now we've defined an array where each of these strings of 6 letters should act as one of our dice. So how do we then turn that into dice? Well, we're going to need to go ahead and create our actual array. So we're going to say Boggle dice equals new Boggle die, and then how many rows do we want? We want rows, number of rows, and cols, number of columns. Now, we've got our array, but now we need to fill it, because keep in mind that creating this array, what values are stored in the array? Nothing but null values, top to bottom. So now we've got to fill the array. So we're going to say for int row equals 0, row is less than rows, go to the next row, repeat again for columns. So call is less than calls, call plus plus. Then on the next row, we're going to instantiate some boggle dice. So we're going to say boggle die or boggle dice row column is equal to, and we're going to call the constructor for a boggle die using this array that we have up here, or B letters array. And which element of the array are we going to pass it? The one pointed to by die index, and we can use this postfix operator to then move on to the next die. That's a sneaky little trick that is commonly used by programmers. Okay, so why do I have, oh, I forgot to set call equal to 0 here. There we go. And now my constructor is done. When this constructor is done, I will have 16 boggle dice, one for each of the die that I've created here. Now what I need to do is write a few methods that I can use to help me work with my board. And the first one is going to be just to return how many rows and how many columns I have. So I'm going to just say public int get rows. And I'm just going to simply return the value of my instance variable. And then I'm going to do the same thing for get calls. Okay, and now I'm going to go ahead and I'm going to scroll this up a little bit. Now, what else do I need to do here? What other methods might I need? Well, I'm going to want some way to find out what boggle die is at any given row and column. So I'm going to write a method that gets the boggle die located, and so I'm going to call it get boggle die at a given row and column. Now, what does that need to do? Well, we're going to add a little bit of safety in here to make sure we don't generate an index out of bounds error. So we're going to say if row is greater than or equal to 0 and row is less than get rows, and column is greater than or equal to 0, and column is less than get calls, then I'm going to return the boggle dice at the given row and column. But only if it's safe to access the array. What am I going to do if it's not? Well, let's just give them back a null value and let them worry about it. It's their program. If they get a null value back, well, that's just their problem. They'll have to handle it. Okay? Well, what else do we have to do? Well, we've got a boggle board here. It'd be really nice if there was some way to easily see the entire boggle board. So what we're going to do is we're going to use the toString method to do that. So we're going to do public string toString, and then we're going to create a big long string that is just a collection of what value is showing for each die in our boggle board. So I'm going to say for int row equals 0. Notice this time I shortened it to just r for row, another common thing that programmers do. And I'm going to say r is less than get rows, and then row plus plus. Do the same thing for the column. Oops, I have to specify the type. So column is less than get calls, column plus plus. And then I'm going to take this string and I'm going to add to it get boggle die at row, comma, column. And I want to just get the face value for this. I want only a single letter, so I'm going to use get current face. And notice as soon as I start typing, I get this really cool interface in Eclipse that lets me choose which method I want. And I want get current face. And then all I have to do at the end is return my string. And I've now got a complete way to simply see all of my boggle dice very quickly. Well, what's the other thing that we might want to do with our boggle board? Well, the whole point of a boggle board is to be able to flip it upside down and shake it around. So what kind of method would we write to do that? And it's very reminiscent of one that we wrote for all our randomizers, only notice this boggle board is not itself a randomizer. So it's a little bit different, but we can still write a method that is void that is called randomize. And what will its job be? Well, it's going to do two things. It's going to repeatedly swap the dice in different locations on the boggle board. That's going to represent the jumbling up of the dice. And then each die is also going to have its facing changed. So here's what we're going to do. We're going to say that if we jumble the dice 100 times, that represents a fair degree of randomness. It certainly exceeds what you would get by shaking the actual boggle board, the physical device. So I'm just going to count from 1 to 100, or from 0 to 99. Okay, and then each time I'm going to generate a random row and column pair. So I'm going to say int r1 equals int math.random times get rows, and int column1 equals int math.random times get calls, and that's going to give me a random row and column, and then I'm going to do a little cut and paste action here to save myself some time. And now I'm going to also make a second row and column, and now I'm going to swap the dice found at these two rows and columns. So how do I do that? Well, first I have to store the boggle die found at my first row and column, and I can use my get boggle die if I want, but in this case it's okay to directly access the array because it's the instance variable of the class we're working in. So we're just going to say boggle dice r1 c1, and then I'm going to put the boggle die stored at r2 c2 in that location. So I'm going to say boggle dice r2 or r1 c1 equals boggle dice r2 c2. And then finally I'm going to take that die that we stored at temp and put it where the original, where the die was that said boggle dice r2 c2. So I'm going to say boggle dice r2 c2 equals temp. And all I've just done is I've swapped the dice located at r1 c1 with the die located at r2 c2. And then finally I'm going to instruct that die to roll itself. How do I do that? Or actually both dice to roll themselves. So I'm going to say boggle dice r1 c1 dot randomize, and boggle die r2 c2 dot randomize. Okay, and that will make the dice that I've just swapped also basically roll themselves. Now, does this algorithm guarantee that every die will have a new side when it's done? And the answer is no. It's very possible that a die could theoretically not get picked at any time. Although there's only 16 positions, and if I'm doing this 100 times, what are the odds that no position gets picked? And if I wanted to change those odds to be lower, I could of course increase this number to determine how many times I want this process to occur. Well, here we go. I now have fully modeled my boggle die class. Now what's left to do is I need to actually test it. And of course, what have we been doing every time we've wanted to test a class we just wrote? We created a runner class for it. So we're going to do class, new class, BoggleBoard runner. And it's going to have a public static void main. All right, and now we simply decide what we want to do. Well, let's make our first test fairly limited. We're just going to say BoggleBoard BB for BoggleBoard equals new BoggleBoard using the default constructor, and then we wrote a toString method. So if we just want to see our BoggleBoard, we should be able to simply do systemout.println BoggleBoard. Let's run it and see what we get. Let's make sure we have the right class selected. There we go. Oh, what did we forget to do? This looks like 16 letters in a row. Let's go back to BoggleBoard, go to our toString method, and I forgot to put a new line in between each row. So I'm going to do s plus equals \n to do a new line after each row. And then go back to BoggleBoard runner and run it. And there we go. Look, I've got 4 rows, 4 columns with random letters, and I can look at this and I can say, okay, are there any words I can see in there? And, well, I'm not seeing a lot. I don't like that one. Let's roll it again. Are the letters the same? No, they're clearly not. Now, how about if I actually wanted to make it so I ran the same BoggleBoard and I showed 3 boggle turns? Well, let's do that. So we're going to say for int I equals, or for int turns equals 0, turns is less than 3, turns plus plus. We're going to wrap that syso, and then in between each one, we're going to say BoggleBoard dot randomize. All right, and then let's also print the turn number there. So we'll put a turn number, and you know what? It'll just be easier here. Let's make this 1 and less than or equal to 3. And while we're at it, let's print a blank line after each one. Give ourselves some space to read here. Okay, let's run our program. And we've got 3. Oh, you know what? We didn't need that blank line because we tossed in an extra blank line at the end of our syso. So let's get at the end of our toString. So let's just delete that and run it again. Oh, I didn't include the turn number. Let's add turns here. Okay. Alrighty. So make that a little bit bigger so we can see it all. Now, what we're mostly hoping for is that I don't see the same thing on each roll. Notice I've got here J in the first position, then W here, then U here. And so this looks random, and it sure looks like it's working. And in a boggle turn, I would basically have 60 seconds or whatever the agreed upon time is to find as many words as I can find. Of course, I'm not very good at this game, so the only word I see right now is ME, and that's not much of a word. Everybody's going to find that one. And remember, to score a point in Boggle, you have to find a word that nobody else finds. So, for example, I found hut here, but that's not going to score me any points because everybody's going to find hut. You need to find words that are harder to find. Okay, so I've got my BoggleBoard and my BoggleBoard runner. Our last task is, you can see that this is not much of a game. To really enjoy the game of Boggle, what we really need is a graphical user interface that allows us to play the game. And for the next lesson, you're going to be introduced into, I'm going to give you some code, and then you're going to put your BoggleBoard and Boggle die into that code and see how your existing code sort of slides right into place and allows us to play the game of Boggle.